Alright, so this is our long question here on kinematics. So initial means that t equals to 0, so which means this point. So now we just have to find it with the function here, key in with the graph, and then g solve y-intercept is y equals to 7, or yeah, so or you can write down v0 equals to 7, that is the same too. And then the maximum speed. Remember, speed equals to the magnitude of v. There's no direction there. So all I need to do is I will do it here. Option, numeric, absolute, y1. The blue is the original one. The red is the absolute one, so I need to change it to negative just in case. Right, so this is our maximum speed. So g solve maximum, but then it's the red one. So this is the first one, this is not that high. I want this maximum because the higher one. So maximum of it is 6.37 and 6.38 actually, and then the other one is 24.7. That is our maximum. Right now the number of times acceleration gets to 0. Acceleration get to 0 means that we have to differentiate it v, right? And then we want it to be 0, which means that we have to differentiate this bit, and again we are too lazy with this, so I do not need the red one. So moving on, I will have option, calculus, differentiation. This time we will swipe 1, but not an exact value for any value for it. This is the only time you can work for the variables with the differentiation. And then now blue is the original one, green is the acceleration. So I wanted to find it, so you might want to sketch it there, so just in case. I got something like this one. Sorry. Yeah, here, and then go back up again. So 1, 2, 3. You sketch it on the graph, that is your working there. So we do have 3 turning points, 3 maximum. Or you can actually, by counting the turning point as well, that's really your choice. And then find the acceleration of p when they change the direction, which is when v equals to 0. So when v equals to 0, this is the time once, and when v equals to 0, t should be, yeah, I'm really using the calculator. G solve, I want the root of the blue one, is t will be equal to 0.86381, something like that. And then now put it back into a 0.86381 would be equals to g solve y cal. This is the green one this time. I want it to be 0.86381. So it's negative 9.2425 there. We have a very powerful calculator, and it's just 2 or 3 points at work, so don't put it too much. All right, now find the total distance traveled by this. So what we need is like from 7 to 0, and then distance is not displacement, so we need to magnitude it, the t. And for this type of hard work, calculator again, manual, matrix, and then option, calculus, integral. So we have 7 cos x minus 5x to the power cos x. Ooh, it's horrible. Remember to magnitude it. Oh, I forgot to magnitude it. Sorry. So it's now we go to option again, numeric, absolute first, magnitude it, and then we have 7 cos x minus 5 x to the power cos x. Now we have 0 to t. It's doing the work, right? Do that, yes. And then remember you have magnitude, so it works for those. So that will be equals to 6.63.9 meters. Remember, when you're reading in the exam, do not write in this page. Write on the line paper, please, because this doesn't count in the score. All right, so you might lose score for it anyway. I don't know whether we count it or not, but this is how we do it. We can see the picture clearly.